ඔය එකට යන්න එක මං කියන්නේ කියලා. nice idea. ලයිව් එක දීලා තියෙන්නේ මේ ගෲප් එක කෑ ගන්න එපා කියන්නේ. ඇවිල්ලා ඇත්ත බයි. මෙහෙම කරු මේකෙන් වහගන්න මට මේක ළඟයිනේ. පාට දුරයිනේ. ෆ්ලයි එක ගියාද දන්නේ නැහැ. දාන එකක් කොහොමද අතට ගත්තා. පොතේ හැටියට එන්නවා. කලින් සීසන් එක කවද්ද කළේ කියලා මතක නැහැ නේ. 19. අන්තිමට වගේනේ ඉන්නේ නේද? එතකොට කට්ටිය අඩු වෙන්නේ. අයියෝ. උඩ ගහ ගන්න. හෙලෝ ඕකේ මේ හතට මේ ෆ්ලයි එකක් යනවාද කොහමද හැපෙනින් නව් එකනේ කැප්ටන් මේ ඒක අරන් දෙන්නම් මම ප්‍රශ්නේ තියෙන්නේ මේ දැන් අර ගෲප් එකේට දැන් ජොයින් නව් කියලා වගේ එකක් දෙන්න තිබුණා හොඳයි කියලා හිතුණා මේ හරි මම මේ මැසේජ් එකක් හදාගන්නවා හරි හරි ඕකේ නිම්රාධ නැහැනේ. ප්‍රසන්ටේෂන් එක ෂෙයා කරන්නකෝ මේ පළවෙනි පේජ් එක තියෙනවනේ ඒක ලූප් වෙවි යනවනේ. මේ මාව ගන්න කියන්නකෝ. සාසින්ද විදිහට ගන්න. දැන් බලන්න හරි. එක්කෙනයිලු ඉන්නේ.
Good evening, everyone. A heartfelt welcome to Revolutionizing Edge Intelligence with AI Agents, the second session of HackElite 2.0, organized by the IEEE Student Branch Affinity Group of the University of Murray. We are truly delighted to have each and every one of you with us today for what promises to be an intellectually enriching session. Before we dive in, feel free to use the official virtual background. It's already shared in the chat, so you can grab it anytime. I'm Dulmini Abhivira and I'm honored to be your host this
Nama kya
evening.
hai?
HackerLight is the flagship competitive innovation challenge organized by the IEEE Student Branch Affinity
Hasa,
Group of University of
Hasara.
Murray. It's a platform for creativity, teamwork, and impact from ideas to prototypes. And today marks the second session of this exciting journey. Let's take a moment to recap HackerLite 1.2 through some snapshots. From brainstorming ideas to moments of creativity and teamwork, these highlights capture the energy, collaboration, and spirit that made the event so special. With HackerLite 2.0 unfolding, we are looking forward to an experience that's even more exciting, inspiring, and memorable. In our previous session, we explored the topic towards autonomous AI systems, a fascinating look into the future of intelligent machines and their real world potential. Now we move to another cutting edge discussion, revolutionizing edge intelligence with AI agents. Together, we will uncover how AI agents are transforming edge intelligence and shaping the next wave of innovation. If you have any questions or thoughts during this session, feel free to join the conversation. Just scan the QR code on the screen and go to slido.com and enter the event code to drop your questions. Let's make this an interactive and thought provoking discussion. And now it's time to welcome our distinguished guest speaker, Mr. Kanishka Wijayasekara, a solutions architect at SON 24/7 with nearly a decade of experience in robotics, embedded systems, and AI-driven solutions. He holds a BSc in Electronic and Telecommunication Engineering and an MSc in Artificial Intelligence from the University of Murray. He was also a qualification winner in NASA's Space Robotics Challenge Phase 2 in 2021. Let's warmly welcome Mr. Kanishka Wijayasekara to take over the session. Over to you, Mr. Kanishka.
Thanks, Dulvini. Hope I'm audible. Am I?
Yes, sir, you're audible.
Perfect. So let me share my screen quickly. Is it visible?
Yes, sir, we can see.
Perfect. Okay, right. So good evening, everyone. Uh, Before we dive into the session, I would like to have a quick, interaction with y'all to get an idea about what our audience is about, right? So I would like to have a raise of hands, like people who are actually, depending on the domain that you are studying right now. So I would like to have, first of all, have a raise of hands in the virtual domain. People who are actually into the software engineering domain. You could be from CSE department, you could be from IT department. How many of y'all have that background? Okay, let's see. Couple of raise of hands. Right, okay, good. Okay, right. And how about electronics and telecommunication engineering? Or anything related to that domain? Electronics, embedded systems. Anyone? Right. And mechanical, or electrical, civil engineering, those domains? No one? Okay, we have one. That's great. And from any other faculties, like it could be, business faculty, anyone from those domains? Okay, right. Interesting. Like, so we have sort of a mixed audience, which I would also like to have. And also I would like to deliver these in a manner that you all get this idea, because this particular topic, AI agents, specifically when you're talking about having that intelligence at the edge nodes, where we usually deal with in our day-to-day life, that's a mandatory knowledge that we should have regardless of our domain going forward, because of this revolution that we are facing right now. So I think Dulmini gave an introduction about me. No need to go forward on that again. So I'll just brief you all little bit about our company I'm representing, SON 24/7. Some of you all may have heard about it, but anyway, I'll just brief you about it. We have been there for more than a decade now, and we are actually headquartered in San Jose, California. At the moment, we have more than 200 engineers working with us, specifically working on multiple domains, and we are working worldwide. We have clients worldwide. We are providing solutions to our global clientele, where it could vary from starting from developing embedded systems, electronic systems, and AI and machine learning components, products, and also software engineering mainly. And we have BA, QA related teams as well. So I would say SON 24/7 is one of the few companies who has the entire spectrum covered in the technology landscape. So, and we are very proud about that as well. Yeah. So when it comes to our main vision, like we know that we all want to provide software solutions and technical solutions to make our lives easier. But at SON 24/7, our main goal is towards adding emotional experience to the solutions that we provide. And to do that, what we do is we bring that to our software solutions, and we try to make sure that our clients receive something beyond that, beyond the technical solution that we are providing. So we are trying to understand the problem in their shoe and their empathies on their requirement and the emotional requirement on the solutions as well. So we are trying to embed that as well. That is also one specialty about us. And we are delivering to a huge clientele, as I showed earlier, globally. Yeah. So when it comes to our spectrum and our expertise in technology, we are more towards, I mean, as I mentioned earlier, we are more towards emotional, bringing the emotional touch to our solutions. So in that, innovation becomes one of the core parts. And in addition to that, we provide RFID solutions and AI and machine learning solutions, enterprise software applications. It could be web, mobile, all these things, and embedded systems. And when it comes to the industries that we are working on, we work on retail, logistics, healthcare, telecommunication, and robotics, all these areas as well. So that is a little bit about the company that I'm representing. Thought y'all should also get some information about that as well. Right. So let's dive right into what we are going to talk today. Now, we know technology has been evolving since, I don't know, since the time that they invented the wheel, I would say. From that point onwards, technology has been evolving. There's nothing stopping that. And if, like, in each phase, something new is being introduced. And of course, if any of those introductions, there'll be a resistance as well. We know at the first level, when steam power engines were invented, people thought that, okay, why would we need that? And then they were proven wrong. And most importantly, when the machines were introduced, people thought that is something that will affect their jobs, and there was a resistance. But at the end, everyone actually had to adapt to that, and still we all have jobs, right? So that is how it is. So as long as we don't resist and we don't try to stop it. What we have to do is we mainly have to look at the opportunities that those new introductions are bringing in, and cope with it, and make ourselves to adapt and get the maximum benefit out of it. So likewise, so far we have come up to about Industry 4.0. That was, I think, mainly introduced about a decade ago, about all these sensors, machines, smart machines, and all these things, and Internet of Things. Everything was introduced at that level. And people were not actually expecting another industry revolution till about, I would say, another couple of decades. But now, with the emerging of AI, everyone has come to a little bit of a doubt, like, are we actually seeing the next industrial revolution? This has not been confirmed yet, but still a huge discussion going around next couple of years. Now, when you're looking at this, so this is what I'm planning to talk today. Now, uh, let's have a quick chat on how the industry has evolved so far, what we have been seeing so far, and what we will be seeing in the future, near future, and going, I mean, I would say another decade or two as well. But I know these predictions are very, very much tend to change, because with AI, what we have today is completely different from what we have yesterday, and what we'll not know what will be invented tomorrow. But only thing that we can do is we can make some assumptions about tomorrow and make ourselves be ready to that change. And as a second topic, I'll be touching on agentic AI, which will be very important for you all, and for us as well. As an industry, we are seeing these AI agents helping us a lot, not challenging us. I'm quoting again, not challenging us, helping us a lot to get the work done better. And another area that I wanted to touch upon this was intelligent machines. Now, earlier we had machines, smart machines, but what's the difference between those machines and intelligent machines? We'll talk about that as well. And we'll have a quick, deep on industry deep dive. I will not go very deeper into this area due to the time restrictions as well. And then we talk about what enables this shift, what is actually fueling this change that we are seeing right now. So that is also very important to understand where this will move forward, and what are the steps that we should take to make sure that we are resilient to this change, and we are not affected by it, but we are benefited by it. And I'll try to give some, according to my opinion, I'll try to give some ideas for you all to prepare yourselves, that how you can adapt better to these technologies, and how you can take this as an opportunity rather than a threat, and make sure that your career will also be enlightened by that, right? And also, if you have any questions, I saw that there's a QR code along with a link to add your questions. Please do add that. We'll try to talk about that at the end if the time permits. I believe we'll have time. I'll try to get to the Q&A section as fast as possible. Right. Okay. Now, what is Industry 4.0? Now, when we graduated, this Industry 4.0 was the talk of the town. Everyone was talking about Internet of Things, and people wanted to get into that, and everyone wanted to make their factories smart, their workflows smart. Now, with this Industry 4.0, the main thing that we got was the availability of data. Now, earlier, we know we had machines working day and night, but still we had no information about how they're performing. It's just the output values that we have. But how the machine is actually performing, whether it is actually making any unnecessary noises, nothing is captured in real time. But they only had was input material and output products. Those are the information that they had. But with the introduction of Industry 4.0, we introduced sensors, Internet of Things, and we collected a lot of data, and we were able to get that information to cloud computing as well, to the cloud, right? So because of this, I would say this is also one of the things that actually has fueled uh, the AI systems that we have today, because even before building an AI system, what we need is data. So I would say Industry 4.0 got us exactly where we needed to be, and where we had to do at that point, by making sure that we have enough data which can be used in future for another revolution. So we should be really grateful for Industry 4.0 to get that, because it got us that luxury. Now, what's the difference between you know, what's wrong about, I mean, I would say not wrong, like when you're talking about Industry 4.0, yes, it is smart. I wouldn't say that it is not smart, but still it was very relied on the pre-programmed logic. Like if something happens, there's an output. That is how it worked, right? But now, when you are going forward, that is not something that what we are expecting. As an example, earlier, if we take uh, a manufacturing plant as an example, what will happen is, if there's a small quality difference, quality degradation in the raw material that we are inputting, according to Industry 4.0, that entire batch will be rejected most of the time, what I'm saying, right? But where we are going today is more like an adaptive system, where if there's any way that we can retain the quality of the final output, even though the input material is having some problem. Say that, okay, if we take as an example the garment industry. So in that case, the raw material may have small patches. For example, it may have small patches in the material that it is we are putting into that. In such case, the ordinary Industry 4.0 factory will have to reject that process, because they have pre-programmed to cut all these fabrics and get the final product done. But as the next generation, what we are looking at is uh, an intelligence where the smart factory can actually identify the areas the quality has been affected, right? Where the quality is not enough, and take that part out, like leave that part out, but still continue on production. Because of these things, we will still remain, will be able to retain the quality of the final output, and at the same time, we will not have to backorder the entire thing just because of some errors in the input material. So that is the level that we are looking at or anticipating as the next level of intelligence in our factories and production lines and all. So this is where we talk about automation and autonomy. Now, earlier we had those automation, we had factories where we had machines, robots, everything is pre-programmed. But autonomy is something where you let your AI systems or intelligent systems to adapt according to the environment. Like if it could be, factory environments, it could be shortages, labor shortages, and it could be, demand increasing of the demand, and supply chains could be, as I mentioned earlier, there could be small issues with the supply chain, and the qualities could be slightly out of order. So in such case, if your factory or if your process is able to adapt autonomously and still get the work done, I would say that is what I refer as autonomy, this formal definition as well. And where we are going next, that is about, as I mentioned earlier, it has to observe what is being coming as the input, and make a reasoning on, like, okay, this has a degraded quality. It has to evaluate it properly. It's not just ignoring that there's a defect or something like that, but it has to evaluate it properly. Okay, there's an issue like this, and this is the particular area which has been affected, but still it should have a goal to achieve. Now the goal is somehow get at least 25 t-shirts done by end of the day, and it will evaluate everything that it has, it knows the goal which has to be achieved, and if the material supplied is sufficient to get that 25 t-shirts done, even by taking out the affected areas, it will still move forward with getting that job done without suspending the entire workflow. So that is what we are looking at as the next level of this. Now, this is where we are going to talk about agentic AI and intelligent machines going forward. Because earlier what we had was feedback program logic, if else logic in simple words, but now it's more towards AI. I'm pretty sure that like y'all are using ChatGPT and all the other LLM based AI tools to get your work done, probably to get your assignments done as well. But in any case, we have to make it a tool rather than a threat, and get our work done smartly. Right. Now, how many of again a quick raise of hands? How many of you have actually worked with any of building? I mean, worked on building AI systems. In any case, it could be training AI model, a machine learning model, or anything like that. Has anyone of you worked on such area? We had a couple of CSC undergrads, IT and CSC undergrads. Hope you all have at least had a module under that, but never mind. So in such case, in the traditional AI, what we had was we have a data set and we train a model, so we can get outputs out of that. Now, what happens is in such cases, we give a clear set of guidelines. This is what you should extract from our data set. As an example, it could be classification. So you give a set of images to identify cats and dogs, discretely identify those two. And also it could be to detect objects. So you want to detect umbrellas out of some images. And also it could be to translate, language translation. So those kind of things we have been working on for the past decade, I would say. But those are all traditional AI. Now, in contrast to that, agentic AI is more towards achieving something autonomously. Now, at the start of an agentic AI, we have to give a goal. So this is what you should achieve at the end of this. And then that agentic AI will run autonomously. It will make a plan. Okay, this is how I'm going to work it. Take this as an example. So you as an AI agent, right? So in that case, I'll take myself as an AI agent. So, okay, so I want to particularly pass an exam. So that's my goal. So in such case, what I'll do is I'll set few plans. Okay, these are the modules that I have to study to get this done, and these are the time periods that I'm going to finish this. And if you get that done before the exam, probably you will pass the exam. So that is simply what an AI agent would do as well. So we'll set a goal, and after setting the goal, AI agent will plan the sequence of steps how to achieve it. And to do that, it is going to use some tools from external environment as well. If it is when it comes to the previous example that I brought in, if it is about passing an exam, it could be the notes that you have and the videos that you have. So you'll be using those tools to get information to achieve your goal. And again, you'll be observing outcomes and adapt. So when you are studying, you will do some model question papers, and depending on your achievement on those model papers, you know that where you are, right? So, and then you see, okay, for this particular area, I'm not getting good marks, but still there's another area I'm getting good marks. So I'll be focusing on the area where I have not received good marks. So likewise, you will observe where you are right now and adapt accordingly using your tools to achieve your goal. So your goal is to pass the exam. So you're not going to pass the exam by just getting one question done. So if you have doing well on that particular question, you will have to work on the other questions as well to get the overall pass on that one. And you will have to interact with the environment as well. In the environment, you will have other people, and the examinations, or all these things are there. So you will have to deal with those cases as well to achieve the ultimate goal. Right. So we have been talking about this AI agents being agentic, and what is this? What is the exact meaning of agentic? I briefly explained this earlier as well. It has to have a goal, and it should be able to achieve this autonomously. And while doing that, you will have to use some tools to get that done. And reflective means you will have to evaluate where you are right now and take decisions accordingly, rather than just moving forward without looking at anything else. You have to do your self evaluation and see if you're actually achieving the goal. If not, you have to adapt accordingly. And also you have to interact with other people, your friends, to get information about notes, and also to get information about the exam. So you have to interact with others as well. So this is simply the way that an AI agent actually works. Now, in most cases, you might think that this AI agent concept emerged recently, but that's wrong. Now we know that AI agents became very smart with the emerging of large language models and things like ChatGPT's GPT models. Because of that, it became more smarter, but still the concept, AI agent concept, is very old. I think it goes back to 1980s. Since then, we have had this concept of agents. So it's just that it got a small bump up with the help of large language models on making decisions, right? Okay, now let me quickly show you a scenario where we have provided a software AI agent to one of our customers. Now, uh, if you talk about this particular use case, now this is a tool rental business that one of our clients carry out. So we have been providing software solutions for them, and they have a fully fledged software tool provided by us. Now that has everything in, borrowing items, lending items, and returning items, everything related to tool rental business, it is there. Now the problem was to retrieve data and make actions on our software system. In any software system, we have to go and we have to be familiar with the system. If there's someone new coming in to use that system, if there's a new employee, it may be really difficult for that person to identify everything in that software and get the work done. But when it comes to natural language, interacting with something in natural language is very easy. Now we know that rather than reading a book to find out an answer for a question, if you can go and ask your lecturer or your friend to get information about that question, that is much easier, right? You always pick that option rather than going and finding that information in another source. Just like that, what we did was we introduced an AI agent through conversational AI, where we can chat with that agent and get the work done to perform the same actions as what we have already provided. So let me quickly show this. Hope you can see this in full screen. So this is the tool that we have prepared. So this one can provide all the printed items, objects, everything, tracking employees, tracking workers, everything is there, right? But as I mentioned earlier, this is a very complex system. When you just, if it is the first time that you're logging in, it will be really difficult to understand all the functionalities that this is providing. But simply, what you can do is you can ask this uh, chat widget that we have at the right bottom to get information about these things. Like if I had to go and find the workers tab and get this information, it will take time. And in the chat itself, I can chat and I can actually filter information. Yeah, I just got the list of objects. Now I want to get only the objects which are overdue. And again, I just don't want to get all the overdue items. I want to get the list of items which are overdue more than 3 days. And then I can actually send notifications from this chat itself. So it will ask me, okay, do you want to send notifications to these people reminding that they have to return these items? We can do that as well. Once we confirm it, it is actually sending an email. So it says that it has sent the email. Now you can see uh, the person who actually raised that, as well as the person who should receive this has received their notification to their email. That could be not just email; it could be other mediums as well, such as WhatsApp messages, text messages. We can do any of those as well. This is another example where we try to get locations. So this is a large tool rental business. This is not a small one like that we have in Sri Lanka. This is a large tool rental business spread across continents. So they have a lot of places, and they want to get an idea about if there are any locations which are under low quantity, where they need to restock and place orders to restock these items. And we can get a list of that, and then we can log the requisition, and also we can order items through the chat as well. We can ask them to uh, reload all the required low quantity items from the chat itself. So that is how we have made this easier for the user. They don't have to actually, if there's anything particular, they can still go to their tabs and check these values. But most of the work, they can do it from the chat itself rather than going through the site itself. I can see like what we have added. They have added this something called the requisition order. Once we added it from there, it will be actually added to the system as well. This is not just showing us a text output, it is actually performing the work. Now, that is where I mentioned by using tools, it will be interacting with the environment to actually perform the work. Now, this is what we have actually logged the. I will go and if you ask about that who has this particular item, it will give me the information. Okay, this particular has these items. Likewise. So that is about software AI agents. Now, I know that software AI agents are now becoming very available throughout different domains. Even ChatGPT is providing their own agentic platform and build your own agents. And if you are working in development side, you have a lot of IDEs providing the agentic behaviors where you can take an agent and tell that agent to get some software built, and it will do it for you right from scratch, like things like Windsurf, Cursor. All these IDs are providing such behavior. Now, I mentioned that AI agent or agent concept is not new, and this is where I'm going to go next is towards physical agents. That is more relevant to our topic today as well. So we know that software agents have been become, I mean, it has become the talk of the town now because of the emerging of agents. But hardware agents, was, I mean, that was not very popular back in the time. Popular, but we couldn't see that a lot in Sri Lanka. But these are some AI agent, physical agents that we have. First, yeah, and there's another version of this does this has food ordering bot that we have built. Once one grab and place an order, in the morning, this robot to bring us the order that is wanted. It will go to it will autonomously navigate through the kitchen. It will request the kitchen staff to put all the ordered items on the robot itself. For this release, it will come back to the place where we ordered it. Just like that, we have built some physical agents as well. Now, if I talk about the first agent, now the role of it is, now you know that in countries like USA, they have large department stores or fashion stores. Like it could be thousands of hundreds of thousands of square feet. It is really, I mean, it is impossible to take manual inventory count of all the items that they have. They can't go by one each, and they can't count everything, even if they have a month or more than that even. So what we have built is this robot which is capable of autonomously navigating. It's just like a self-driving car. If someone comes in front of, it will know how to navigate around that person rather than hitting that person. It is fully equipped with LiDAR technology and depth cameras to get the autonomous navigation. So what it does is, once the store is closed, it will unplug from its charging dock, and it will navigate through the entire sales flow to do an RFID scan. RFID is radio identification, radio frequency identification. So using that technology, you can get an idea about what are the actual items that you have in that flow and the counts as well. And it will do the entire run throughout the night. And in the morning, when the store is about to open, it will come back to its charging dock, and it will dock itself for charging. Then it can start working on next day as well. So the goal is to count all the items in the sales flow, and when it is trying to achieve that goal, there will be challenges. So it will be following a set of steps where it knows that, okay, I'll be first be going through this particular department first, men's section first, and then the ladies section, because those are adjacent. So likewise, it will have a plan, and it will have tools like RFID readers to get information from the environment. And if something happens on the go, if there's an obstacle in front of it when it is trying to move, it will try to navigate around it. And at the end of the day, it will come back to its dock, and it will upload all the data to the cloud environment that we need those data into. Those data is needed to do all these analytics and report generation. So similar to that, in this one also, the goal is to bring food to you. And if something comes in front of you, it will try to avoid it and get the work done. So that is how agents work. Now, you can see there's no large language model sort of thing involved, but still these are agents which are capable of achieving a goal and get the work done, right? And most importantly, it is autonomous. It is autonomous to avoid. It doesn't need humans' attention to get the work done. It will try to resolve everything as much as possible, and still, I mean, it will get the work done. Right. And then we will come to now. This is where we have to. I wanted to talk about this. Like, we know that there are software AI agents, and when it meets the embodiment or the physical capabilities, it becomes a hardware agent as well. So now, in the past, we had robots in the factories. You may have seen that there are a lot of robots. If it is a car manufacturing factory, there are so many robots that could work, right? Now, the difference here is, earlier, if a single factory is programmed to do one task, it will only do that, right? So we have a set of robots set up to build a car. You will not be able to do anything in that particular factory. But that is going to change, in my opinion. Now, we know that demands are, we can forecast demands, but still that is not very accurate. So there'll be some periods of the year that you will not be able to build your primary product. Say if it is a car, say that you have met your demand, you have completed your demand, building the demand, and I mean catering to the demand. But beyond that point, the factory will be idling. Now, when you are moving to the next phase of these intelligent factories, uh, the prediction is it will be able to adapt accordingly. So the same factory built, cars might be able to build some other furniture as well. As an example, it's a bold example, but yeah, you can think of something like that as well. Because the reason is the robots will be not something that is pre-programmed to have very rigid behavior. So it will be able to look at the material and handle the material accordingly. And uh, in addition to that, so there could be like that is when it comes to the context of factories, manufacturing factories. But in addition to that, this could be related to things like construction sites and retail domains as well. So the next example, I will show you an intelligent machine where we have built to dispense, uh, now when it comes to construction sites, let me tell the story first, then you'll understand this better. Now, we have another client where they provide similar domain, providing tools and consumables like nuts and bolts into remote locations like mining sites, those kind of areas. Now, the biggest problem with these areas is it is really difficult to find manual labor in these areas, because if you have to keep someone at that area, that is going to be very difficult, more than the money as well, but still more than the amount that they have to pay. It's really difficult to find labor to stay in these remote locations and do the work. So this client, they wanted to introduce something that will reduce the requirement of manual interference to this process. So what we did was we built a few solutions for them. One is being an industrial vending machine. So what we do with that is that is basically a cabinet sort of a thing where they can go and tap in their employee card, and the door will open, and they can pick items from, I mean, say if it is nuts and bolts, they don't have to keep someone to dispense that nuts and bolts to that worker. Like, it's just a very basic task to be done. Even I mean, self-service is more than sufficient to get that task done. So in that case, what you can do is you can open the door, you can take in all the required items from that cabinet and close the door. Now what happens is we have weight sensors in each of these buckets, and we can identify by using the weight how many items that they actually took, and we log that information. And when the quantities are going low, the machine will decide when to reorder, because we know that having I mean hard cutoff, hard threshold value to reorder is not going to help in many cases. As an example, say I have two items in this cabinet. One is gloves, the other one is nuts and bolts for a particular size. Now I know by looking at my past data, if I have 10 pairs of gloves, it is going to, I mean, it is going to be enough for more than a month. But if I have 10 sets of nuts and bolts, it is not even going to last a day. So depending on the past consumption of each item, it will automatically adjust the reorder thresholds in this particular machine, and it will actually make the reordering autonomously. So that is where we are making these machines intelligent. Hope I explained it enough. So let me show you this video. I think it will come up next. Yeah. After that, before that, I will explain this as well. Now, when you're trying to make a machine intelligent, so in that case, of course, we need sensors, and we need computation to process this information from uh, uh, from the sensors, and if there are any actuation need, like as an example, to open a door and to move a robot from one point to another, we need actuators. Those are the actuations. And decision making, we could have multiple levels of decision making. It could be just a simple if else logic as well, or it could be an LLM powered agent as well. And also we need communication to inform other parties like the cloud system about if there's a low quantity situation, we have to inform it to the cloud as well. So this is a classic example that I have added. You saw that robot in the previous slide, right? Like, so it is capable of navigating autonomously to reach some sort of a goal without hitting any obstacle. So in that case, what happens is, now we use this platform called ROS, Robot Operating System. That's a framework that we use to build robot navigation system. So in such case, we get sensor data and we get robot's location, and we try to achieve that goal. We get a target goal. The robot try to achieve that goal. And how do we achieve that goal? We give our motors a command. Okay, you should roll and you should move forward. And while we are moving, we get a feedback from our sensors. Okay, like we are moving. Are we moving into the right direction? Again, by using sensor data, we can get an idea about our current location as well. So we were there and we are here now. Okay, are we going towards the goal or are we moving away from the goal? So likewise, using that information, you can control your motors to reach that goal. So that is how you make a machine intelligent, get the information in and evaluate the sensor data and make an action, and then revisit to see that if we are actually achieving the goal that we have been asked to achieve. Okay, right. This is the machine that I mentioned about. Let me show this.
Imagine you're on a
This
busy construction site or deep inside a mine.
is it audible to you guys? Is the audio available to you guys on the video? Can you hear it?
Yes, sir.
Okay.
While you're working, you realize you need some nuts and bolts, but your supply is actually very far away or close. What is it? It's a waste of time, it's a waste of productivity. Now imagine there's a cabinet, a secure, safe cabinet which is steps away. You just tap your card, grab what you need, and you walk away. No paperwork, no hassle, no nothing. This is the smart innovation of Zone 24/7. It goes by the industrial vending machine. This is not your average vending machine. It is specifically built for harsh and tough climates in an industrial environment where mud, dust, and 24/7 operations are taken place. Why is this machine so special? Each and every component is sitting on a tiny scale. So the machine knows exactly the amount of component you remove from this weighing machine. This machine also has the capability to measure and accurately know the number of components, even a small nut like this. So let's see what else this machine offers. This machine is built to be very secure. Only an authorized person with an NFC card can gain access to this machine because it tracks everything and it is sent to a cloud server where the managers have full visibility. Moreover, this system also tracks the inventory in real time. So you don't need to worry about running out of stock because this machine will alert the suppliers as soon as the stock.
That is same thing that I explained earlier as well, because the time is running out. I'll move forward.
Okay. Imagine your
Right. Now, let's have a quick look at like where we have these intelligent machines today. Now, when it comes to manufacturing, we see a lot of robots working in our manufacturing sites, like factories, to take material from one point to another, and finished good also being transferred from transported from one point to another using autonomous mobile robots, just like what you saw in that food delivery component, food delivery video. So just like that, robots are capable of doing that transportation. And AI control robotic arms to adapt to the I would say small defects that we have in the material. According to that, it will have to change the gripping direction, sort of things. And those are the ways that we can make these industries intelligent. And retail, self scanning robots to get an idea about what are the low stock items. It will be passing through aisles to scan everything. These type of robots are very common in countries like USA, that they move through aisles, capture all the videos, and get an idea about uh, the low stock items and place the orders as well. And smart vending machines, just like what you saw earlier. And for logistics, sorting to get items, depending on their weight and size, you can sort everything, and you can autonomously take it to the relevant bins that you have to put it into. And delivery drones, and health in the healthcare industry, we have surgical robots, and helper robots to get the help to elderly care as well. So those are the high level ideas that we have right now. Not the ideas, these are actually being served right now. These are the things that they have actually introduced intelligent machines at the moment. And this will be evolving further in future as well, because we know that there's a bunch of uh, humanoid robots coming out, I would say next couple of years. Even some are being released this year. So these robots can be highly customized. They can be used in any sort of these requirements, and the industries will be very intelligent going forward. Okay, what enables this shift? Now we know that this AI revolution, AI has been there for a very long time, as I mentioned earlier, from 19, I don't know if you have heard about these, John McCarthy, and all these people have been in Minsky and McCarthy. All these people have uh, founded, I would say, AI, artificial intelligence, at least the term back then. And from that point onward, it has been evolving. But the biggest breakthrough happened a couple of years ago when large language models came into the have picture. Founded, like I would say, things like OpenAI. I mean, companies like OpenAI built and introduced these GPT models, which actually changed the mindset of people. I mean, when we are talking about AI, I would say 5, 6 years ago, we were mainly thinking about sci-fi movies only. But these companies actually made it a reality, and from that point onwards, people actually started believing in AI. That's the main reason. That is one of the main reasons why we are seeing this shift so rapidly, because this was supposed to happen through a longer time span. But now it seems like everything that we knew yesterday is updated today. Same thing will happen for tomorrow as well. So it is going very fast. LLMs are one of the top fueling components of this shift. And vision, audio, sensor fusion, because we know that hardware industry is moving parallelly on their own as well. So they are trying to improve the sensors that they have, build better sensors with less noise. So by using those, our AI systems can get a better understanding on the environment, like what is actually happening in the environment. Just like what we see in the environment, the robots and the AI systems will also be able to see in a couple of years. And this agentic architecture, it has been there for quite some time, but it was redefined and made advanced by the introduction of LLMs and its reasoning capability. Because earlier we know that all these LLMs came in as just conversational models, just like NLP. But then we got the luxury of reasoning as well. Now the LLMs are capable of telling you why it is saying that. Like when we ask a question, it says, okay, because of this reason, I'm giving you this particular advice. So that is a huge thing for agents, so they can make decisions better. And hardware and infrastructure maturity, of course, with the emerging of NVIDIA's GPUs, they introduced the superb series of GPUs where it enables, because I think the concept of LLMs were also there for some time, but to make it a practical, uh, we didn't have the luxury of hardware. But with the introduction of these GPUs, it was actually made a reality. And we have robotics platforms and communication improvements, because no matter what we have in our, how no matter how the technology is being advanced, if we don't have a way to communicate in between those two entities, like two intelligent entities efficiently, it is going to be inefficient. And simply you don't have to go that far. So with all these the speed that you need to transform, I mean, send data from one point to another is very critical for an agent to be usable. Now, when I'm chatting in that previous tool rental business video, if it took me like 5-6 seconds to get that information to the cloud and process it and bring it back, it is not going to be usable. So because of those technologies also, we have got the luxury to make it more practical and usable. And feedback loops and learning in the loop. So we can observe by using the sensors, and we can give information back to our system, so it will learn better and it will adapt better to provide better answers and all. Right. As the last section, I wanted to talk a little bit about, like in my this is my own opinion. So this could be different going forward with the emerging of next technologies that we see in next couple of years. But at the moment, by looking at the industry landscape and by talking to my peers, this is where we see this will go towards. And now we know earlier problem, I mean, task doers, so actually people who are executing was the did had the I mean they had the spotlight, right? But now, if you take some AI agent and ask it to build some software that you want to build, it will actually do. I wouldn't say that it is 100% good, but it will do a pretty decent job. But what is different is framing the problem, where you'll have to look at a customer's pain point and understand, okay, what is actually required, what is the best solution for this. If you can frame that problem and find a solution to that, then I feel like you are going to have a pretty good advantage over others. I mean, people who are just looking at doing the task. Rather than that, if you can actually focus on a problem and find a solution, then you'll be able to get that easily done with the help of AI as well. So this is a good area, in my opinion, to build your skills on. This is not going to, I'm pretty sure most of y'all are undergraduates. I know that you may think that, okay, how do we do this? Because we are not in the industry yet, but I disagree with that. Even when you come to the industry, so the number of problems that you will get to solve, at least in the first few years, is will be very low. So what I would say is, what I suggest is, you have to, whenever you see a problem, try to do a problem framer and try to find a solution for that. This is a practice that you have to build up, and by practice, your brain will also get used to this, and you'll be able to solve problems easily. And invest in AI fluency. Now we know that uh, most of the things that we used to do manually, now we can do using AI. But you have to be very, very responsible in when you are doing that, because you have to know what is actually happening behind that. I'm not against using AI for to get the work done, not your assignments, of course, but if you want to build something quickly, I'm more than okay to get the help of ChatGPT, or any coding tool that you have, AI tool, to get that done. So, but The catch is you have to know what is actually happening behind that. You just go to that and type it in and get the output is not going to help you. But if you can dig in a little bit and see what is actually happening and how this crazy thing is getting this work done this fast, then you will be have the upper hand over AI. Then you know how to manipulate this AI to get the work that you want to. So I would say not just use it, you have to use it, but don't use it as just you have to, because just because you have to use it to get the work done. To know, you have to know what is actually happening underneath and why and how this is being done by AI. And number three is also something similar to the first one, but little bit it is little bit an extended version of point number one. You have to take a multi-dimensional look at your problems to arrive on a solution. As an example, first of all, you have to practically see how to solve this. That is number one. Okay, you see a problem. Okay, you see this is how I'm going to solve it, and then you know that how you are going to build the solution. Now you know the solution. Then you have to think, how am I going to build that solution in a way that I'll be able to handle future scenarios as well, right? And how I can make it extendable, the solution, to solve other problems as well. And then system thinking is you have to look at your system. How would I put it? How it will be integrated to other parts as well. As a system, you will be providing a solution, and that system, how it will be integrated with other components end to end, how it will make the impact on your overall goal. And ethical reasoning, and you have to, I mean, we can find solutions in many ways, but you have to look at it in a sustainable way. This is the solution going to retain, and is the solution going to introduce any social impacts on the society? So those things are also very important when you look at a problem. So those are the meta skills that you have to build. And fourth point is again bit related to the second point I mentioned, build an experiment. So you'll not be able to get the experience when you come to the industry. Before even that, if you can at least, I mean, in your mind, you can work on solutioning and maybe spend a little time to build small solution and experiment how this is actually being useful. This is, I think, going to help us a lot uh, to introduce solutions to the industry also. So those are the things that I had in my mind to cover today. And yeah, this is about the role that you have to play. So if it is a development role that you are looking at, you have to look at, you know, engineers who will be able to automate workflows and get the redundant work down to zero as much as possible. And there are human-centered roles that you'll be able to, you know, get your job role done by just prompting in some cases. So likewise, there are, I mean, a lot of ways that you can use AI to your job roles. So those are not going to be very applicable right now, but I'm pretty sure when you're graduating, you say that you are in second year, third year, but by the time you are graduating, uh, this is a very important thing that you have to have the AI proficiency to get the work done. That is the most important thing while knowing what is actually happening behind the scenes. So that is my advice in general. Uh, yeah, so I think that's all I had in my mind. If you all have any questions, can answer.
So there are some questions in the chat also.
Yeah, let me check. Right. Okay. This is a good question. Asking about agentic AI and statistical symbolic AI, and how to more like this. Right. So it's more like this now. To identify an anomaly, I know that when you are switching in between use case, I hope I'm getting this right. Like first decision is identifying which flow to execute. What is your goal right now? Now, if we are locked into one goal, then all of a sudden inputs of another goal should not appear. In such case, of course, it will be taken as an outlier and it will be treated differently. I believe that's what you are asking. So in such case, in an agentic system, first of all, agent should identify what sort of execution goal is being assigned to you. And depending, selecting that goal is, I mean, that could be a different agent's work. Identifying the current situations, work schedule, and assigning you the goal. That could be a role of a human or could be an agent as well. But once it is assigned, you are assuming that decision was correct. In such case, you will have everything aligned to that particular process where you will not see outliers on that one. Have I answered that, Gishani, or is it wrong? Have I got it wrong? And we make agentic AI models as a hybrid version of both analyzing data parameters and based on logic, not just only on ML. Yes, yes, of course. So now, you may have heard learning-based AI and cognitive AI. Have you heard of that? So those two areas have come together because agents are coming under, as I can remember, cognitive AI. Rule and logic-based systems are also coming under that area, and I think genetic algorithms, not genetic algorithms. And on the other hand, we have deep learning, machine learning, which are learning-based approaches of AI. So as an example, now, if you're a person who are learning, for an example, same example I'm taking, so there are two ways that you can enhance your knowledge on that particular domain, or how you can answer a particular question paper. One would be by practicing and learning. Then you practice some questions and you can answer that. But there are some questions you can't do like that. You have to logically think and solve. So those are the two areas of AI as well. So where we have cognitive AI and learning based, machine learning based AI. Now, uh, now what we can do is we can take both of them as a hybrid system as well. So I'll bring you an example. We have one of our products called Cognitive Vision Analytics Platform. So in that platform, we have machine learning models, object detection models to retrieve spatial data from the video frames. People, how many people are there, and whether they are, I mean, their genders, age. We get all this information from spatial information. So that what we use is learning-based AI. And beyond that, we need to get information in the temporal domain as well in subsequent frames, like from this frame to the other frame. We want to identify, okay, there was a person wearing red color t-shirt in the first frame, and we want to identify where that person is in the next one. For such cases, we usually don't use machine learning based approaches. What we do is we develop a logic and rule based algorithm for tracking. So in such cases, what we do is we use an hybrid method to get the overall done. And even in an agent, we can use hybrid approaches to make the decisions. Ishani, have I answered your second question? Right. Yeah. So it is very, I mean, it is pretty common using an hybrid approach to get the work done in agents as well as our AI systems. It's very common. Okay.
If you have more questions, please post them through Slido and we will be bringing them to our speaker.
Okay, I think. Okay. Right. Okay. So a couple of questions about the company. Uh, so all of our opportunities are usually, posted in our careers page. Uh, I think there'll be some positions being opened, but not confirmed yet. But I would ask you to keep looking at keep in touch with our social media and our careers page. Whenever that we have an opportunity, we advertise it there. So that will be the best way to get in touch on the available opportunities at Zone 24/7. Can we connect only to the Sri Lankan Zone 24/7 or not? That actually depends. Mostly at the moment, because our entire engineering team is located here in Sri Lanka at the moment, but there are some opportunities coming up again. Once such case emerges, it will be on our careers page. Okay, right. So when it comes to agentic AI, what I would say is this is very obvious because building an agentic AI agent is very simple now because all the frameworks are there and how to do that, the tutorials, and even there are agents building AI agents. So you just have to be proficient in uh, communication. If you can tell it properly to the AI agent which is building the AI agent, you can easily build it. But what I personally value a lot is having common sense on solving a problem by looking at by looking I mean having a look at the 360 of a particular problem and solving this particular problem. uh, when it comes to technology stack at the moment, what I'm saying is this is relevant to current technologies that we have on our plate, but this will be different from today to tomorrow. uh, you will have to have coding skills, Python skills at least, because that is, even though we can generate code, there should be someone to evaluate how good it is and all. So having programming knowledge, at least on Python, is mandatory. And having your understanding on how machine learning model, particularly deep learning and machine learning models work, the fundamentals of it is very important because uh, even though that we can get the work done easily by LLMs, you should know how it works. So starting from basic machine learning models to deep learning models to LLMs, you have to know how these transformers work. So I really value having that knowledge on these deep foundational knowledge. And in addition to that, having software engineering knowledge on API calling, databases is slightly valuable. Not the core area of agentic AI, but still valuable. And yeah, communication skills you have to improve a lot. You have to know that how to tell or how to instruct an AI properly to get that work done. Right. So when it comes to usual interview processes in general, what in my opinion, this is not the exact process will be followed by all the interviewers, but still, uh, in my opinion, you have to be very knowledgeable on Python. Not the syntax. I wouldn't really value the syntax, but you have to know about the concepts. Like even though you get the writing wrong, there could be spelling mistakes, mistake in the words or keywords that you are putting in, but still you have to have an idea about why we do that. As an example, if I ask you about opening a file, if you say that, okay, we can do it by using with open, I don't mind you saying it is with open or anything, any mistake on the syntax particularly, but you have to know, if I ask, okay, why did you use with open or such block? Then you should be able to say, okay, that is because when I use with open block, when I go beyond that block, the file is automatically closed. In such validations should come from you. That is number one. And you'll be evaluated on data structures and algorithms, how to solve a problem. That is mainly to get an idea about how capable you are to solve a problem. And when it comes to AI, there'll be questions on foundational knowledge of deep learning architectures, like what does a CNN do, convolutional neural network do, and how does it work, like those kind of information. And when it comes to agentic AI related questions, you will be having questions like uh, what are the differences between how can you actually fine tune a model to cater your particular requirement? How can you do that? What are the ways that you could use RAG? You could use fine tuning. You could use multiple ways of prompt engineering as well. So likewise, those are the things that will be useful in my opinion. But this is based on the technologies that we have today, but it will be completely different tomorrow. That's how the AI domain is. As an undergraduate who's following AI degree, I would like to know how many roles relate directly for us, our company right now. Okay, so to answer to that, uh, so on 24/7, we have been in the AI side for quite some time. We are like early adapters. So in that case, we have a couple of projects on computer vision domain. So we have computer vision related cognitive vision AI engineers who are working on computer vision side and extracting information and fine tuning models and altering architecture slightly to get the model to work perfectly. And on the other hand, we have generative AI related roles as well, where we are developing our agentic platforms. So in that area, you will not be directly training models on that area, but still you will have to build agents and interact with LLMs. In some cases, you will have to implement pipelines, RAG pipelines, and also there may be requirements of uh, uh, fine tuning LLMs. Those are also there. And recently there's this emerging technology that I feel like it'll be better if you guys can follow on that area, where deploying small language models specifically on edge compute or not edge computers in on-premise servers. So fine tuning a small model, I would say 1 billion, 7 billion, up to that level, and hosting it in a environment where you can locally access, because of data privacy issues and everything. Sometimes people are much interested in that area. So those are the roles that we have. In addition to that, we have MLOps roles as well. But that is just to set up all the pipelines developed by other engineering roles to ensure everything runs smoothly. And if there's any deviation in accuracy, they'll be noticing it and allow other engineers to work on it promptly. Yeah, so those are the areas that we are usually working on. Right, I think.
Seems like no more questions. Thank you so much, Mr. Kanishka, for sharing your insightful knowledge and experience with us. Your work is truly inspiring, and the clarity with which you explain Such a complex topic has made this session immensely valuable for all of us. As a token of our gratitude for taking the time to be with us and for sharing your valuable insights today, now we would like to present a token of appreciation to Mr. Kanishka Wijayasekara. Your contribution has made a significant impact on everyone here, and we are incredibly grateful for it. Thank you, sir.
Thank you, Dhirmini. Thanks, team, for inviting us. And hope you all gain something out of this. And if you have any other questions related to the session or trends in the industry, you could reach me on LinkedIn. Yeah, that's it. Thank you.
Before we conclude, let's capture this moment together. We kindly request everyone to turn on their cameras. The virtual background is already shared in the chat. Alright, everyone, get ready. Let's count down. 3, 2, 1. Another one, please. 3, 2, 1. Thank you all for being part of this memory. To formally conclude this session, now I invite Ms. Sulakshani Disanayakar, the program lead of HackElite 2.0, to deliver the vote of thanks on behalf of the IEEE WIA Student Branch Affinity Group of University of Moratuwa.
Good evening, everyone. As we come to the end of this wonderful session, it is my privilege to express heartfelt gratitude on behalf of HackElite 2.0. First of all, I would like to extend my sincere thanks to our esteemed speaker, Mr. Kanishka Wijayasekara, for sharing the invaluable knowledge and insights. Your expertise has truly enriched our understanding and sparked new ideas. A big thank you to all the participants for your enthusiastic presence and active engagement. Your thoughtful patience and contribution helped make this session interactive and meaningful. I would also like to acknowledge the efforts of this organizing team behind the scenes. Your dedication and coordination ensure the smooth flow of the session from start to finish. Last but not least, a heartfelt thank you goes to the IEEE Student Branch Affinity Group of University of Moratuwa for organizing HackElite 2.0 and for providing undergraduates this valuable platform to showcase their talent and enhance their skills through such an inspiring competition. Let's carry forward the learning and inspiration from today as we continue to grow and collaborate. Thank you once again and good night.
Thank you, Ms. Sulakshani. Thank you to all participants for your engagement and enthusiasm. We hope today's session has sparked new thoughts, inspired fresh ideas, and opened your mind to the wonders of AI. Signing off, I am Dulmini Abevira. Until we meet again in our final day, stay curious, stay inspired, and good night.